Hello friends, welcome to aimstoday YouTube channel. Now we are going to see IIT-JEE NEET Foundation Chemistry chapter, that is atomic structure. In that part 2 we are going to see. In this we are going to discuss about the discovery of fundamental particles like electrons, protons and neutrons. First let us see the discovery of electrons. Who discovered these? The existence of electrons in an atom was first time shown by J. Thomson in 1897 by passing electricity at a high voltage through a gas at very low pressure in a discharge tube. Here we have to see what is discharge tube. A discharge tube is a long glass tube invented by English physicist William Crookes. It consists of a long cylindrical glass tube sealed at both the ends, and it is fitted with two electrodes at the opposite sides. These electrodes are connected to a source of high voltage. This discharge tube is filled with a gas or air, and its pressure is regulated or controlled by using a vacuum pump. By using this discharge tube, J. Thomson produced cathode rays. Thomson passed electricity at a high voltage through the gas at a very low pressure taken in the discharge tube. Then he detected that a stream of particles was coming out from the negatively charged electrode to the positive charged electrode. He called these rays as cathode rays, which were later on called as electrons. So when he passed high voltage current through this discharge tube, he observed that some particles are coming from these negative electrode side to positive electrode side. He called these as cathode rays, and later on we came to know them as electrons. Now let us see the properties of these cathode rays or electrons. These cathode rays travel in straight lines. They are independent of the material composition of the cathode. Applying electric field in the path of cathode ray deflects the ray towards the positively charged plate. Hence, these cathode rays consist of negatively charged particles. J. Thomson measured the charge by mass ratio or E by M ratio, which is also called the specific charge of cathode ray particle, using deflection in both the electric and magnetic field. By that, he found that the E by M ratio of electron or cathode ray particle as minus 1.76 into 10 to the power of 8 coulomb per gram. The cathode ray particle turned about to be 2000 times, to say exactly 1837 times lighter than hydrogen. Although we got E by M ratio for electron from the J. Thomson's cathode ray tube experiment, we still don't know the exact charge for the electron. American physicist Robert Millikan designed an experiment to measure the absolute value of the charge of an electron. That is MILLIKAN'S oil drop experiment. In 1909, Robert Millikan conducted the oil drop experiment to determine the charge of an electron. He suspended tiny charged droplets of oil between two metal electrodes by balancing the downward gravitational force with upward drag and electrical forces. By this experiment, he found that the charge of electron is to be minus 1.602 into 10 to the power of minus 19 coulombs. Then let us say about the discovery of protons. The presence of positively charged particle in an atom had been first observed in 1886 by Eugen Goldstein, based on the concept of atoms are being electrically neutral. While he was working with cathode ray tubes, found that in addition to these electrons that are traveling from negatively charged plate, there were some other rays that moved in the opposite direction to these. In the previous experiment, we have observed that these cathode ray particles are moving from negative electrode side to positive electrode side. In the same experiment, Eugen Goldstein found that some other particles are moving from positive electrode side to negative electrode side. He called these particles as canal rays or positive rays or anode rays. The same particles were again found and proved to be as protons by scientist Rutherford in 1909 by his experiments. Further, he postulated that hydrogen nucleus to be new particle, and he named it as proton from the Greek word protos, which means the first. These are the two scientists done works on the discovery of proton, but the total credit of discovery of protons is given to Eugen Goldstein. Now let us see the properties of these anode rays or protons. Anode rays travel in straight line. Anode rays are positively charged material particles. Anode rays may get deflected by external magnetic field or electric field as they are charged particles. Unlike cathode rays, their E by M value is dependent on the nature of the gas taken in the discharge tube. It is maximum when the gas present in the discharge tube is hydrogen, whereas we have seen that the E by M ratio is independent for cathode rays. Now let us see the discovery of neutrons. By 1920, physicists came to know that most of the mass of the atom was located in a nucleus at its center, and the central core contained protons. In May 1932, James Chadwick announced that core also contained a new charged particle which he called as neutron. He bombarded the element beryllium with alpha particles. He observed that beryllium changes to carbon, and thus neutrons are emitted in the reaction. Here we have to know what are these alpha particles. Alpha particles are generally emitted by radioactive elements and are helium ions. That means with the bunch of 2 protons and 2 neutrons. That's why you say these as helium ions or helium nuclei, which are containing a doubly positive charge on them. Now let us see the properties of these neutrons. Electrically, a neutron is neutral. That means it has no charge. In a particular element, the number of neutrons in the nucleus of its atoms may vary. That means atoms of the same element may also have different number of neutrons in their nuclei. Now let us compare the properties of these electrons, protons and neutrons, like mass, charge and this. If you see here, electrons charge is minus 1.602 into 10 to the power of minus 19 coulombs, whereas the charge of proton is exactly same quantity but it is positive charge. That means 1.602 10 to the power of minus 19, whereas the charge of neutron is neutral, 0. It has no charge. By comparing to the masses, the mass of electron is very low when compared to the mass of the proton as well as neutron. To say accurate value for the mass of electron, it is equal to 9.11 into 10 to the power of minus 31 kgs, whereas the mass of proton is taken as 1.672 into 10 to the power of minus 27 kgs. The mass of neutron is a little greater than that of proton, but to say in general, mass of proton and neutron are generally taken as considered as unity. It is 1.674 into 10 to the power of minus 27 kgs. The same values are taken in AMU. See here, the mass of electron in AMU is taken as 0.00054 AMU, and the mass of proton and neutron are generally considered as 1 AMU each. But to say accurately, mass of neutron is a little greater than that of proton. Thank you for watching our video. Please subscribe our channel and please press the bell icon for receiving